today's topic is codes and standards that are applicable for lighting design. And we're going to dig into the details here and hopefully give you some good tools to help you start working on Team Project 1. So let's go ahead and jump into that vocab and discuss how these terms are used in the regulatory ecosystem that we need to address as lighting designers. So starting with guides, including the IES Handbook, the primary purpose of these is to provide practical design guidance, and the focus is usually on best practices. There'll also be quantitative design criteria because this is engineering after all. And these are going to almost always be voluntary, and they're not legally enforceable because they're not written in legally enforceable language like some of the other things that we're going to look at today are. Standards. Standards are providing design guidance through a set of requirements. So unlike design guides, which are providing you a bunch of subjective criteria and decision-making information, a standard is going to be laid out more like a set of requirements. The goal of a standard is usually to create clear expectations among non-professionals for the standard of performance or the standard of work being done. And typically that's going to be accomplished through a set of, again, standardized quantitative performance criteria in a way to demonstrate that your good or service is similar in quality to other goods and services that comply with the same standard. Now, standards are typically voluntary. Where they'll be required is going to be in the project specifications. So most importantly, usually we're talking about LEED when we're talking about a standard that's applied in the project specifications, usually in the owner project requirements. Standards are written to be legally enforceable, and I say ish because, for example, LEED, the individual clauses themselves are not written to be legally enforceable. So it's difficult to take LEED piecemeal. And so instead, what you would do is you would take the entire standard, including the governing body that oversees the certification of LEED projects. So that would be the level at which it's legally enforceable if a municipality is insisting that all new building projects need to be, say, LEED certified or LEED silver. ASHRAE is kind of an interesting standard. It's called a standard on the title, as you can see over there on the top right side of the slide. However, when you actually read the content of ASHRAE, it is written in legally enforceable code language. Now, the reason why we typically call ASHRAE 90.1 a standard is because it has a code counterpart, and that code counterpart is the IECC, which you can see down there in the bottom right. So codes are going to be systems of requirements. So it's lighter on design guidance and heavier on very specific legally enforceable clauses and requirements necessary for compliance with that code. And the goal of a code is to provide government entities, including the federal government, state governments, and all the way down to municipal governments, a set of requirements that they can mandate in law. And so the language is going to be a little different because it's typically applied by regulation. And that's why we need it written in legally enforceable language. And that's one of the key differences between, say, ASHRAE and IECC, which are otherwise quite similar in their content and intent, is the IECC is written in more generalized legally enforceable language. Okay, and finally, regulations are the final piece of this regulatory ecosystem. And so the regulations themselves are going to be what mandates that we use a particular code or standard. Now, this is where it can get complex because the regulations aren't necessarily required to take every single piece of the code. And in fact, a lot of states will adopt, say, IECC minus the compliance paperwork aspect. So they're not actually performing oversight, which does remove some of the teeth from that code. Now, you can take this further. You can actually impose additional requirements. And I think the most well-known example of that is California's Title 24, which goes above and beyond IECC and ASHRAE requirements and applies an additional set of requirements that is particularly needed in those particularly high density population zones. Now, the other aspect of this is that reporting requirements will vary greatly by jurisdiction, usually on the state level. But as we dig into this, some states don't actually adopt these codes statewide, and it's left to counties or municipalities to do that. And so, for example, in the state of Colorado, you can have very different reporting requirements depending on which side of a county line you're on. But don't worry, I'll highlight some tools that we have to clarify those differences and understand what we need to do to comply with these regulations in any particular area in the US. For non-US projects, there are other tools, but for this class, I'm focused just on US regulatory requirements. Okay, so I don't want to go into a whole lot of detail here. This is just a bunch of references for the things that I've talked about so that you have a way to directly link in without ambiguity what I'm discussing. I think the biggest thing out of this chart here is actually going to be this energy code compliance help right here. The DOE provides a lot of information to help you understand what the specific requirements are going to be for your project depending on location. So obviously, if you go to Canvas and grab the slides, then you'll have these as a set of clickable links. Okay. I'm not going to spend a whole lot of time on the IES Handbook because I know you've all already been using the IES Handbook for a lot of projects so far in other classes. So I'll just refresh real quick in case anyone needs it. So within the IES Handbook, we have a hierarchical organization to find the specific design criteria recommended for your specific visual task. You're going to need to start with the building type. So that'll get you the section or the chapter of the book that you need to be in. So in this case, this table here is just common applications. However, there are chapters for specific building types like healthcare and museums and schools and so on and so forth. Once you're in the correct building type, keeping in mind common applications are always going to be superseded in the IES Handbook and as well in ASHRAE by the specific building type recommendations. But once you're confident you're in the right building type, then you're going to look for your general space type, for example, conferencing. Then you'll have groups of activities like video conferencing, and then the specific visual tasks. So that's how you work your way down the hierarchy to identify the specific recommendations most appropriate for what you're doing. And then, of course, if we expand that table, we can see here that we have our selected visual task, that front screen projection. And if we just follow it along the row to the right, we'll eventually get to our illuminance targets, which you can see below me. At that point, you select the age of your observers. So in this example, this is selecting the criteria for a front screen projector in a typical classroom. So we're looking at average age under 25. So that gets me a lower illuminance target often. We don't want to forget our gauge. In this case, it's max. So it's not just 50 lux, it's 50 lux maximum. And that's very different from 50 lux average. In this case, we're trying to limit the light on that projector screen, not have a minimum level of light. And then, of course, we have uniformity ratio recommendations. And for all of you, as you're becoming more nuanced in your lighting design practice, I think it becomes more and more important to look at aspects all the way on the right side of these tables, like I have below me. And so that's going to provide an additional set of recommendations, aspects that are important and worthwhile to be considered for your specific visual task. In the case of front screen projection, it's indicating below me that glare is a thing you should consider, but maybe not the dominant consideration. That's why it's grayed out. But you still should consider glare on basically any kind of screen. Okay, let's move on from the IES Handbook for now. And let's talk about ASHRAE 90.1. Okay, so this is where things get messy. Don't worry, we have some great tools available to us to clean this up. So I'll start with this DOE order that I have linked up at top. And what this order states is that all states should adopt ASHRAE 90.1 2016 by no later than February 2020. Okay, so what is the reality of that state level adoption? Because DOE can't actually mandate this directly. Well, it's a mess. It's literally all over the map. So we have some states, those dark green states are the ones that have currently adopted ASHRAE 2016 or better. However, that is the vast minority. And so for the rest of the country, we're left with a rather complex landscape of differing regulations and differing levels of regulation. So this map is probably not where we want to be, because we're going to want to dig into that in a little more depth. So let me bring us back to the IECC first. And the reason why we want to start here is because this is the code version of ASHRAE 90.1. And in fact, most states in their regulations are going to mandate IECC, not ASHRAE 90.1. Cool. So why are we talking about ASHRAE 90.1 then? Well, that's because it's typically listed as an alternative compliance path within the IECC. And in fact, there's been a lot of efforts in the recent editions to harmonize the requirements between the IECC and ASHRAE because they're basically standardizing the same concept, which is how should we write our building codes in order to make more effective use of energy consumption. So ASHRAE 90.1 is going to be specified in the IECC as a compliance path. Both of these documents are updated on roughly a 3-year cycle. So you'll see ASHRAE 2016, but we already have ASHRAE 2019, which is currently under review by the Department of Energy. The IECC editions are typically released 1 to 2 years behind the ASHRAE 90.1 releases. And so in this case, what you'll see is a state mandating IECC 2018 is essentially saying that you can comply with IECC 2018 or ASHRAE 90.1 2016. In other words, those two standards for your intents and purposes are equivalent on this front. So if you're seeing IECC 18, subtract 2 years to get the addition of ASHRAE that you want to comply with. Now, again, in these regulations, some states are going to omit certain sections of the IECC. And of course, some states, for example, California, require additional compliance. On top of this, there's a lot of complexity with respect to what you need to report to demonstrate compliance. And that's going to vary greatly from state to state, and even in some cases, county to county. Whew. So what do we do with this regulatory zoo? We're going to go to the DOE. And in fact, that specific link right there is going to take you to a part of the DOE website where they detail exactly what requirements you're going to need to comply with on a state by state basis. And we'll dig into this with the group work here at the end of the session. So don't worry, we'll come back to that. Feel free to click the link now. The main thing you'll see there is specific compliance software tools, which are extremely helpful, both in general and for your upcoming project. But what's a little less obvious on that page is actually a state-by-state dropdown. So you can select a state and it will take you to a page that details exactly what they've adopted, which version of ICC or ASHRAE, and if there are any additional provisions with respect to reporting or aspects omitted, so that you can see exactly what you need to comply with. And those software tools also available on that same page are going to be able to interact with those specific state-by-state level requirements. Cool. Let's get back to ASHRAE then. So how do we use ASHRAE? Most of you are already familiar with this. I know that we discussed this in 311 as well as 461 is where this would have also come up. So we're going to use the space by space method to get our lighting power allowances. So in terms of our total wattage, that's the goal here, is to calculate the total wattage we're allowed for lighting throughout our entire project. And the way we do that is by taking all of our spaces, defining them within the definitions available inside of ASHRAE 90.1. And when we identify those spaces, it's going to give us an LPD, and that's going to be in terms of watts per square foot. So we simply modify those space by space LPDs by the square footage of the space in question. That'll get you a wattage. If we sum all of those wattages across the entire project, this is going to give us our total allowed wattage throughout the project. And that's the number we need to comply with when we're complying with our total installed lighting power. Now, keep in mind, these are not bulb wattages. These are not necessarily even fixture wattages. They're entire luminaire wattages. So it's what wattage goes into that luminaire from your electrical system, and it's not looking at component level wattage. And so while we calculate these wattages in a space by space manner, we're not actually complying on a space by space level. So this allows us to trade wattages around throughout the building, which is important for lighting design practice, because what that means is that you can often have more freedom, say, in your lobby to install some purely decorative lighting that isn't necessarily helping you with your design criteria from the IES Handbook, but nonetheless is great design practice. And maybe we go over our allowed wattage in a lobby area or another area of high interest and trade that off by installing fixtures well below the expected efficiency level in spaces like corridors and storage and so on and so forth. So we can trade those wattages around because we're just trying to comply with the total calculated wattage for our entire project. There's also, if you really want to get into the sticks with ASHRAE, there's extra credit available. So you can increase your allowed wattage by installing better control systems than what the standard explicitly requires you to do. And there's also room geometry allowances. This is usually applicable to particularly tall spaces, because the LPD requirements are based on the general idea of a ceiling height somewhere between 9 and 15 feet. And so if you have a 2-story atrium, then the allowed power density might be too low for that space. And so you can get an allowance based on the specific geometry of your room for that. And that's known as the room cavity ratio, or the room geometry allowance. Okay, so here is a table from ASHRAE 90.1. I believe this is 2016 is what I pulled up here. These are, again, available online for free, so you can use the link in that references slide to find this exact information for yourself. But I would like to take a moment to dig into this table. So there's a couple aspects here. So somewhat similarly to the IES Handbook, you're going to have a hierarchy for looking these values up. So we start right here with building type. And so the building specific recommendations, again, like the IES Handbook, will supersede the recommendations for general spaces. So if you have a library or have a manufacturing facility, you should use those recommendations ahead of the common application types ones. So you start with your building type, then you find your particular space type, and that's as far down the rabbit hole as you need to go. And that's going to get you to your lighting power density, specifically in terms of watts per square foot. That's what you multiply with your square footage to get your total wattage. And then finally, over here to my right are the controls requirements. Now, oftentimes we can satisfy this whole set of requirements with one or two controls that take care of the whole set. This is specifying control outcomes, not control devices. And so that's up to us as lighting designers to figure out the most effective way to meet these requirements while still meeting the needs of the occupants in our space. And so that brings me to the concept of sustainability, specifically with respect to the LEED system. Okay, so the LEED system, or the Leadership in Energy and Efficiency Design, was originally released in 1993. It's administered by the U.S. Green Building Council, as you can see up there at the top of the slide. And the current version is version 4. That was released in 2015. We also have version 4.1, and despite the 0.1 in its name, version 4.1 is a substantial update to version 4. And that was released in 2019. And that's also the version that I specified for your projects, because if you're going to familiarize yourself with any version of LEED, you might as well familiarize yourself with the upcoming version that's more likely to be relevant as you enter the workforce. So the whole concept of LEED and sustainability, and I think this is really important to point out, and this is a topic I'm passionate about, because in my past life, this is what I specialized in, was sustainable design when I was environmental engineer. And so the concept here is not just green design. In fact, green design is missing 2/3 of the purpose of a truly sustainable design guideline. And so what we're looking at instead is actually what is called the triple bottom line, or I like to call it the 3 Ps: people, planet, and profit, or prosperity is actually my more preferred word. But it's the crux of all 3 of these concepts coming together that gets us to true sustainability. If we're ignoring the needs of our users, of the actual occupants of our space, of the people in our space, then we're not addressing the actual needs of the building. If we're ignoring things like energy efficiency and water consumption, we're ignoring our future. And importantly, also, a lot of people don't realize that LEED does actively engage with the concept of profit or prosperity. The design guidelines set forth in LEED are not intended to be punishing to businesses and to developers, but rather to encourage best practices that may have a higher upfront cost, but a lower life cycle cost. And so LEED is fairly cautious not to advocate for solutions that don't actually improve cost over time. And so that is the lead concept of sustainability, is this triple bottom line of people, planet, and prosperity, and a truly sustainable technology and a truly sustainable building practice accounts for all three of these aspects, not simply green design, not simply user acceptance, but rather the confluence of all three. Okay, so we have four major systems, and within each of these systems, there are a variety of building specific modifications to each one. The one you're going to engage with the most is the one at the top, and that's new building design and construction. So that's the lead system for new buildings. Interior design and construction is a system for certifying the build out of interiors. So a lot of commercial spaces. So if you think of, say, a mall, what the developer is doing is building a shell, and the actual interior of that space is going to be handled by a totally separate group that is renting that space from the developer. And so interior design and construction can be very different from core and shell. Then buildings operation and maintenance recognizes that it's not just the construction of the building that matters, but how we manage that building over its life cycle that really gets us to true sustainability. So there's a separate system of guidance and criteria for sustainably managing a building, and that's going to be an O&M. And then finally, the newest version of LEED is neighborhood development, and this is looking at a higher level, more of a city planning level, and what steps municipal planners can take to make entire communities more sustainable. You're probably already familiar. There's 4 levels of certification, and this has everything to do with how many points you accrue through the various credits. Typically, certified and silver level buildings are very good about the prosperity part of the triple bottom line, and you'll see that reaching a certified or a silver level in a building really just amounts to good building design and not so much aggressive green design, whereas the gold and platinum levels are more heavily weighting the people and planet sides of that triple bottom line. Okay, so there are 6 core categories. There's also innovation to design, a regional priority, but I don't want to get into too much detail here. I just want to give you a broader overview of what you would expect to find within LEED. So here's our 6 major categories. And I went ahead and added the lighting related credits here under the categories where they appear. So these are the major credits. There's also prerequisites that are relevant to lighting, specifically in energy and atmosphere. You don't get the advanced commissioning credits without the fundamental commissioning prerequisite. And commissioning building systems includes especially commissioning the control systems, such as the lighting control system. And so that's how lighting ties in with commissioning and as well with energy metering. Indoor environmental quality is more focused on the people portion of our triple bottom line. And so within that, we're going to see credits for interior lighting. And specifically, what this is getting at is controllability, user level controllability of lighting instead of just large scale controllability for entire spaces full of people. Daylight, of course, is crucial to user acceptance and well-being within that space. And that is separate but related to quality views. The entry-level LEED certification is just simply the LEED Green Associate. So if sustainable design is something that you're interested and passionate about, I know there's a variety of classes within the university that can give you more depth of understanding in this than I have time to provide. But also the Green Associate certification has no prerequisites. You just need to take an exam demonstrating fundamental knowledge of LEED and sustainable design concepts. And the basic study materials are available for free. So that's a certification you can consider as you're getting ready to graduate. I just want to point that out as something that's available to you as a certification to demonstrate your interest in this aspect of building design. Okay, so let's talk about light pollution. And so that sustainable sites credit for light pollution reduction is directly referencing the model lighting ordinance, which is a code or an example code rather, that's provided to help municipalities take steps to reduce light pollution within their cities. So the code is focused on exterior luminaires. Interior luminaires are a lot less relevant to this conversation. You do have some light coming out windows, but our big culprits are the stadium. I mean, all exterior luminaires, especially the stadium. Kind of hate the stadium sometimes. Anyways, so there are two main types of light pollution that we're interested in. The first one is light trespass, and specifically what light trespass means is light that's going off the edge of your property into your neighbor's property and say illuminating their yard at night or shining lights in their bedroom window at night that they don't necessarily want there, but don't have an ability to prevent because the lights are located on another property. So light trespass is an important concept. And then of course we have sky glow, which is probably the what you think of when you think of light pollution. So the way we define this is by starting with our lighting zones in the ordinance and identifying which lighting zone that we're going to be in. And I just realized I left off the lighting zone table. So let me grab a link so that I can send all of that to you. There we go. Okay, so model lighting ordinance. There's the link on Canvas, so you can take a look at the lighting zones because I'm about to ask a question about the lighting zones. And that's going to determine how aggressively we want to restrict light pollution is going to depend on where we're doing it, right? So if we're in downtown State College, we're probably less concerned with the levels than we are, say, in Rothrock. So there are two compliance paths proposed within the model lighting ordinance, and for your project, you're going to be engaging with both compliance paths. The first one is the bug rating, and that is focused on the performance of luminaires themselves. And then you have the calculation method, and you're going to need to do that using AGI 32. And that's a more nuanced, more holistic method because that's calculating all of the light that's leaving your project at the boundaries of your project rather than just focusing on the luminaires. The bug rating is going to be easier to apply and easier to understand because you can usually get bug ratings on your luminaire cut sheets for exterior luminaires. So let's take a look at bug rating. So specifically bug, B-U-N-G, it's an acronym, and it's getting at three types of waste light coming off of a luminaire that's not benefiting you directly, that's not explicitly going towards the goals of your project. So the first one is backlight. And so if we have an exterior fixture oriented in the fashion shown, let's say this is at the edge of our property, this backlight zone, so this bottom quadrant right here, is all waste light that's likely to escape the project boundary. So this is an aspect of the distribution that isn't terribly useful to us for our projects, and yet can make us bad neighbors. And the next part is uplight, and this is again the more conventional concept of light pollution. That this is this component of the light that is just escaping directly into the sky. And so this is the both one of the easiest to fix aspects of light pollution, and also one of the most problematic aspects of light pollution is the uplight component of our fixtures. What's not included in the bug rating, which is addressed in the calculation method, is reflected light off the ground. So that's going to contribute as well, but not nearly as much as light sources that just shine directly up into the sky, like the stadium. And then finally, we have glare. And so glare is not actually an aspect that's explicitly called out in the LEED credit for light pollution reduction. This is more on the people side. So these are the high angles of light that are close to horizontal that are much more likely to get in your eyes. And so for interior luminaires, this is what we use things like egg crates and baffles for, is to block these high angles that that can glare directly in your eyes and bounce off your computer screen. And then finally, we have the calculation method. And so instead of focusing on the luminaires, this is going to require calculation of light at the project boundary. So you're going to need a full model of your project, for example, in AGI 32. And so the way we calculate this is again in two components as specified in LEED, as well as the model lighting ordinance. And so the first aspect is the conventional sky glow. And so that's going to basically, you'll place a boundary at the top of your project, and then you're going to calculate the total amount of lumens that are going directly up, and as a percentage of the total lumens emitted by all of your luminaires. And that's going to give you the metric required for compliance with the component related to sky glow. And then light trespass, what we're doing is calculating the vertical illuminance. So not the horizontal illuminance, but the vertical illuminance on an imaginary plane at the project boundary, right? So that's how much light are we shining into our neighbor's yard. And so there are some excellent AGI 32 tutorials on this topic that will help you set up those calculation planes and get these specific values necessary to demonstrate compliance with the model lighting ordinance, which in turn demonstrates compliance with the LEED credit for light pollution reduction and gets the building site another point towards their LEED certification. All right. Well, that concludes my my overview of codes and standards relevant to lighting design. I know there's a lot that goes into this, so that's why I tried to provide you a really robust set of links so you can follow up with this and make sure that you actually understand the codes and understand which codes apply to your project.